sometimes when we want to make a graph of a new function, maybe we just have to do some translations and maybe some reflections and maybe make the graph taller or maybe like shorter, narrower, wider, things like that. In this video, I'm going to give you guys 3 examples on what I mean by that. We are going to describe how the graph of the following, like this, can be obtained from the graph of the original. We are not given the graph of the original, but based on the operations, we can tell how to get the new graph. So let me talk about the first one right here. Y is equal to 4 times f of negative x and then minus 5. Do this kind of inside out. We pay attention to the negative x first. What does this do compared to the original f of x? Well, even though the graph is not given, but I will still give you guys like an example along the way that can help you guys see what's going on. So this is just like an example. Let's say we have the original looks like this. So this is f of x. Well, if we have f of negative x, we see how we just negate the x values. So instead of the positive x values, we actually just kind of go to the negative x value instead. So we will actually just do a reflection and the graph will look like this. Reflection about the y-axis. So that's exactly what this do to the original. Alright, so we just have to kind of write this down along the way. So the first thing that we have is, I'll just write this as the first, reflect the graph of the original, so we'll just say y is equal to f of x about the y-axis. So that's step 1. Step 2 is that we see this guy is multiplied with the 4 now. So let's talk about what will happen when we multiply by the 4. So let's see. Right here, you see that we just multiply the 4 outside of the function. Whenever it's outside of the function, it's about the y values. So when we have f of negative x already, which is this piece, if we multiply this by 4, what's going to happen is we'll just take this and then stretch vertically. So we are going to have a taller graph like this, just stretch it vertically. So for the next part, I'm going to say step 2. We stretch the graph vertically by a factor of 4. By a factor of 4. Of course, if you have 10 right here, that's multiplying with the function here, it's going to be taller. So that's why we mentioned by a factor of whatever. Lastly, we see that we just have to minus the 5 after all that. So let's see what will happen. We have this piece already, so let's look at 4 f of negative x. But then in the end, we are going to minus 5. Minus 5 to this means that we just have to bring the function down 5 times. I'm not sure what this number is, but just imagine that we just kind of brought it down 5 times. Like that, right? 5 times. So we'll just write that down right here. Lastly, we'll just say
step 3, we shift the function, the graph down right there. So shift down 5 units. This is good enough. Yeah.
So step 1, step 2, step 3, based on what's happening over there. Okay, for number 2, we have y is equal to negative f of x plus 2 and then plus 1. So do this inside out. We see that we are adding the 2 directly to the x. So what does that do? I will give you guys a picture first. So suppose this time, I'm going to give you guys the function that say looks like, like this. Doesn't really matter, just, like a square root graph, okay? Alright, anyway. What's happening here is that when we add the 2 directly to x, we move this 2 units to the left. So the new picture will be like this, right? And right here we will have negative 2. So step 1 is that we shift the original, so let's just write it down, shift the graph of y is equal to f of x, 2 units to the left. Right? So that's the first step. And then we see that after this, we multiply by the negative, right? Negative f of that. So what does the negative do? Well, for the negative, it's a reflection about the x-axis. So you see, this is what we have. And again, let me just give you guys a picture right here. We have f of x plus 2 already from here, but if we have a negative on the outside, this is a reflection about the x-axis. So the picture will look like this. All right? So step 2 is, it's a reflection, so just say reflect about the x-axis. Cool. And lastly, we will just have to add 1 right? And then the 1 is after all that. So we'll just have to bring the function up by 1 unit. And I really enjoy this kind of questions because it really tests you to see if you can identify what's going on with the functions and also associate the operations and also the translations of the graph. But anyway, the +1 right here, let me just write this down one more time. We add a 1, so that means we bring the function up right here, so 1 unit like this. Alright, so lastly, the third step, I'll just say we shift this up, right? So shift 1 unit up. And we are done. So for part C, unfortunately I cannot hold the Pokeball. Hopefully you guys don't mind. But we're going to see how to graph the inverse of f. This notation means the inverse of the original function f. Yeah, I'm going to give you guys this picture for the original, right? So if you take a look right here, suppose this is the original, then let me just write down f of x. Well, how can we get to the inverse? This is what we do, right? We just hold this diagonal and then we flip that and we get this. And hopefully you guys can see that we have the curve like bleed through the paper. This right here is exactly how the inverse will look like, provided that the original function is 1-to-1, of course. So let me just give you guys the picture right here. Just get this instead, right? So this right here will be the inverse. So let me just say we inverse the function like this. All right, and the idea is that we actually just do a reflection about this diagonal. Okay, again, let me just show you guys one more time. Here's the original, and then we just flip that, and that's how we get this. All right, so the only thing that we have to do is this right here is just reflect the graph of the original, which is just y is equal to f of x, about the line y is equal to x, because that's just a diagonal. And yeah, that's it. So I think this is really fun. Let me know what you guys think.